Hey everybody, this is Danielle. We are going to look at section 19.2 in this video. And in this section, you are going to solve right triangles using the same rules we learned in the last class. You'll either use sine, cosine, or tangent, depending on which part of the triangles are given to you. For the first part of the homework, we're going to start using the sine function. You will know that you need to use the sine function because you will have one of the acute angles, which means one of the angles that is less than 90 degrees, and you will have the side that is opposite to that angle and the hypotenuse. If you're ever given those three pieces of information or asked to solve for one of those three pieces of information, you will need to use the sine ratio. And to get the sine of the angle, you take the opposite side length divided by the hypotenuse side length. So let's look at our first example. The first one I have for you, you have this triangle and it's asking you to find angle A. So we are looking for how big that angle is, and they gave us the side that was across from the angle, so they gave us the opposite side. And they gave us the long side of the triangle, so they gave us the hypotenuse. So because of that, we know that we need to use sine of angle A is equal to the opposite over the hypotenuse. Now, since we are looking for how big angle A is, we won't fill anything in for A, but we know that the opposite side has a length of 7, and that the hypotenuse has a length of 21. Now, we're trying to figure out the size of A. So to figure out the angle, that is when you have to turn to inverse trig. So to find out how big angle A is, we'll have to take inverse sine of 7 over 21. Now, for almost all of the homework problems, they do want you to find the answer in degrees, so make sure that your calculator is in degree mode, and you can just type that straight in, sine inverse of 7 divided by 21 in parentheses, and you should get your 19.4712 degrees. Make sure to pay attention to the directions. They want you to round to the nearest tenth. So that would be 19.5 degrees. If we look at the next problem, it wants us to find a side length. It wants to know how big side A is. So again, they gave us the angle that is opposite side A, and they gave us the hypotenuse. So since we have an opposite side and a hypotenuse, that again is going to be sine. So sine of angle A is equal to the opposite side over the hypotenuse side, just like we did last class. This time, though, they told us that the angle was 53.5 degrees and that the opposite side length is unknown, that's our A, but that the hypotenuse side length is 15. Now you're going to have to do a little algebra here to get the A isolated. And in this case, the A is being divided by 15. So to undo division, we would have to multiply both sides by 15. So A is going to equal 15 times the sine of 53.5. And you can type it in your calculator just like that, and you will get an answer of 12.0578. You will need to pay attention to the directions and how far they want you to round. It didn't say in this case, so let's just pretend that they said to round to the nearest hundredth. If that was the case, we would round to 12.06. Sometimes they won't be so specific, but all they'll ask you to do is to solve a triangle. So if they tell you to solve a triangle, what do they mean? In that case, they want you to find the measure of all the sides, and they want you to find the measure of all the angles. Okay, so let's look at example 3. In example 3, they have asked us to solve triangle DEF, and in this triangle, they told us technically two angles because they gave you a 90-degree angle and the acute angle. So to find your final missing angle E, you just need to do some subtraction. So you know that there's 180 degrees in a triangle. Deduct your right angle of 90 degrees and you'll be down to 90. And then deduct your acute angle of 32.5, and that'll tell you how big angle E is. So in this problem, angle E is 57.5 degrees. Okay. Now, you can also use that piece of information to find your other sides. For example, you can use it to find the side that is missing across from angle D. They're going to label that with a lowercase d. Okay. And since you know the angle across, oh, just kidding. If we find E, the problem is we're missing the hypotenuse. The hypotenuse is unknown, so we wouldn't be able to use the angle, sorry, the 32.5 we could use, but we would have to switch to tangent because we don't know the hypotenuse, so we can't use sine. We could use tangent though. Tangent of angle D is equal to the opposite over the adjacent. And in this problem, we know that angle D is 32.5. We are looking for the opposite in this problem. Give us a little room. And we know the adjacent is 24. So to solve for your D, you could multiply both sides by 24. Use your calculator to type that in. 24 times the tangent of 32.5. And you'll see that side D is approximately 15.3. Now the good thing about this is now that you know two side lengths, you know that this side is 24 and you know that this side is 15.3. You can use those to find your hypotenuse by just doing Pythagorean Theorem of a squared plus b squared equals the hypotenuse squared. So if we typed that in, we would have our 15.3 squared plus our 24 squared, which would equal 810. And then to find out the value of C, we would need to square root that. So our C is approximately 28.5. So in that last problem, I used tangent, but sometimes you can also use cosine. And again, you're going to know when to use cosine. It'll be clear because they will provide you with an adjacent side and the hypotenuse. And when they do that, you can use the ratio that cosine of the angle is equal to the adjacent side divided by the hypotenuse. So for example, if we look at number 4, I gave you the hypotenuse of 3.6 and the adjacent side of 1.9, and I've asked you to find out how big angle A is. So we know that the tangent of angle A is equal to the adjacent side over the hypotenuse side. So in this problem, our adjacent side is equal to 1.9 and our hypotenuse is equal to 3.6. Now, whenever you are looking for the size of an angle, you are going to need to use inverse trig. So to figure out how big angle A is, we will need to do inverse tangent of 1.9 divided by 3.6. You can type it in your calculator just like that, which is what I'm going to do. And you will find out that the size of angle A is, sorry, that wasn't clear, is 27.8 degrees. So again, just depending on what they provide you, will determine which calculation that you get or use. So in this problem, they want us to find side B, which is adjacent to angle A, and the hypotenuse is provided. So again, since we're dealing with an adjacent and a hypotenuse, we can use cosine of A equals adjacent over hypotenuse. And they gave us the angle in this problem as 19.5. They gave us the hypotenuse as 42, but the adjacent side is unknown. So to isolate the A, we just need to multiply both sides by 42 and type that into our calculator. So angle A is equal to 42 times the cosine of 19.5, and we will get a side length of 39.6 approximately. Do make sure you're labeling that centimeters. Okay, let's do one more like this. This time we are looking for how big side T is. Notice side T is across from the right angle. That means they are looking for the hypotenuse. They have provided an angle of 55 degrees, and they have provided the side adjacent to 55. So since we have an adjacent and we're looking for a hypotenuse, that is going to be cosine. So cosine of the 55 degree angle is equal to the adjacent side over the hypotenuse. Now, if you want, what I like to do is I like to think of this as a proportion, and I just put my cosine of 55 over 1, and that helps me to think of it as cross-multiplying, which just in my mind makes a little more sense. And then you need to get your h isolated, and h is being multiplied by cosine of 55. So you will need to divide each side by cosine of 55. And again, make sure you're in degree mode. So the length of your hypotenuse is equal to 15 divided by cosine of 55 degrees, which is approximately 26.2. So they will take these processes, and they may also ask you to use tangent, which we already did one earlier. I think I slipped an extra one in there on you. And again, you'll know to use tangent because they'll provide you an opposite side or an adjacent side. And so when that is the case, you'll use the tangent ratio, which is tangent of theta is equal to opposite divided by adjacent. Okay, so let's look at this situation here for number 7. I'm asking you to figure out how big angle A is, which is down here in the bottom left-hand corner. I've given you the side opposite of it, and I've given you the side adjacent to it. So that should tell you that you need to use tangent of angle A is equal to opposite over adjacent. And it's the angle that's unknown, but the opposite side was 14 and the adjacent side is 16. And remember, whenever you're looking for the angle, you do need to use inverse trig. And you can type it in your calculator just like that. The inverse tangent of 14 over 16, you don't have to reduce it. It will still get you the right answer. Just make sure that you are in degree mode when you're looking for an answer in degrees. Let's try one more like that, but this time they gave me the angle and they are looking for a side length. So again, they gave me an angle of 44.5 degrees. They've asked me to find the opposite side, and they provided me the adjacent side. So we can say that tangent of 44.5 degrees is equal to the opposite side over the adjacent side. And to isolate your a value, you would have to multiply both sides by 6. And so you can type that directly into your calculator, 6 times tangent of 44.5. And let's see what we get. We should get an a value of approximately 5.9 centimeters. Okay, one more problem like that. In this situation, they gave me the angle size, they gave me the opposite side, but they asked me to find the adjacent side. Okay, so again, since I have opposite and adjacent, we're going to go with tangent. Tangent of the angle, which is 19 degrees, is equal to the opposite over the adjacent. And I'm going to do like I did before, where I pretend that I'm solving a proportion and that I'm going to cross multiply. So I'm going to have b times tangent 19, and I'm going to have 1 times 10. And I will solve for b by dividing both sides by tangent 19. If you prefer to turn tangent 19 into a decimal, you can. It's usually a little cleaner to just leave it. So we can type in our calculator 10 divided by the tangent of 19 degrees, and we should see that side B is approximately 29.04 centimeters. So sometimes they'll go real generic and they won't tell you what method to use. And so in this case, you're going to have to decide. And so what you need to do is you need to figure out what parts they have given you and what parts are unknown that they want you to calculate. And then you have to pick the function that best fits the situation. Okay, so let's look at number 10. In this problem, they want me to use triangle ABC, and the first thing they want me to do is figure out how big side C is. So side C is my hypotenuse. Okay, now you can use trig if you want to, but you sure don't have to because they gave you two other sides of the triangle. So you can say a squared plus b squared equals c squared. That's the most straightforward way. We know that 9 squared is 81 and that 6 squared is 36. So if we were to add 81 and 36 together, we would get 117. And then to get our value of c, we'd have to square root 117, which is not going to be a nice number, but they did ask for 4 significant figures. So when you type that in your calculator, you get 10.81665, blah, blah, blah. So 1, 2, 3, 4 sig figs. So we would say 10.82 is our C value. Now, in addition to that, they also want us to figure out how big angle A is. Now, you could use the C value that you just calculated. I would avoid it just in case you made a mistake, especially if it was a test. And instead, I would use the values that were given. So they gave you the 6, which is opposite of the A, and they gave you the 9, which is adjacent to the A. So in that situation, I would go with tangent. We know that tangent of A is equal to the opposite side over the adjacent side. And remember, whenever you're looking for the angle, you need to use inverse trig. You do not need to reduce the fraction, you just need to type it in. Do make sure you're in degree mode. Oops, I didn't use inverse tangent when I typed it in. And so in this case, our angle is approximately 33.7 degrees. Okay, last but not least, they can give you applied problems. Applied just means story problems. Same thing, you're going to have to figure out what parts you don't know, what parts you do know, and then you pick which function that you think you should use. Okay, so if we look at number 11, it says, there's a typo there. That should say a jet takes off at a 30-degree angle. If the runway from takeoff is 875 feet long, find the altitude of the airplane as it flies over the end of the runway. So we're looking to see how high the airplane is at the end of the 875-foot runway if we know that we take off at a 30-degree angle. So using that information, keep in mind you know the angle, you are looking for the opposite side, and you know the adjacent side. So that would be tangent. Tangent of the angle is equal to the opposite divided by the adjacent. And then to get your x alone, you'd have to multiply both sides by the 875. And you can do that directly in your calculator by taking 875 times tangent of 30 degrees. And you will find that at the end of the runway, the plane is 505.2 feet high. Let's look at one more similar to this. Okay, a stretch of road drops 30 feet for every 300 feet of road. So that means if you go, you'll have a decrease in height for every 300 feet of roadway. The question is, what's the angle of declination? So basically, what angle is this decreasing at? So we are looking for the angle, and they have given me the side opposite of the angle, and they've given me the hypotenuse. So opposite and hypotenuse relate with sine. Sine of the angle is equal to the opposite side over the hypotenuse. And then remember, whenever you're solving for the angle, that is when you use the inverse trig. And we're going to type that in our calculator and figure out how steep the angle is. So we'll do inverse sine of 30 over 300. There it is declining at approximately 5.7 degrees.